Good morning and welcome to today's class. Today we'll be working on motion. Remember the father of motion, Sir Isaac Newton. And we have the calculations here. We have 5 calculations. You can pause the video and write out the questions. Now let's go to the solving immediately. Now for question number 1 here, we're using one of the first equation of motion to solve, where we have your v is equals to u plus at. Now your u here is the initial velocity. Now if you look at the question here, your initial velocity here was given 60 km per hour. So therefore quickly teach us how to convert from kilometer per hour to meter per seconds quickly here. When you have kilometer per hour, if you want to convert it to meter per seconds, remember kilometer to meter 1000, hour to seconds, that is 3600, 0.0005 to here 5 to here 18. So you have 5 over 18. So whatever they give you in kilometer per hour, just multiply with 5 over 18. For the question they gave us 60 kilometer per hour. So I can just do 60 times 5 over 18. So I will get my 16.6766 in meter per seconds. So that is the first thing I want to teach us. So that is the solution to number 1. Just equate u plus 80. The same thing too for number 2. So for number 2, we are looking for our t. Number 2, they made mention of the word decelerate. Deceleration is negative acceleration. If acceleration is speed, acceleration is increasing, positive. Deceleration will be negative. Alright, so that is that for that question now. Now I want us to follow. Let's go to number 3. Number 3 here, they say we should find the distance. Number 3 says find the distance. If you are giving us distance, we have another equation for motion that we're making use of. S is equals to ut plus half at square. Your u is your initial velocity, which is 10. Then t is time taking 30. Then half at square. Remember that your t are square in 30 times 30, which is 900. So we get our answer in meter. Remember that speed should be in meter, or 4.8 kilometer. We are converting to kilometer divided by 1000. Then number 4, another equation for motion. If you look at it now, we have like 3 equations for motion. The equation for motion is just indirectly saying the formulas under motion. For number 4, look at number 4 question. A body moving with an initial velocity of 30 meters per second square accelerates. Now, there's something I want to quickly teach us. This is a cheat code. Let's look at number 5 too as well. Number 5 is very easy. What I want to bring out for number 5 is that a ball is released from a height. Now, initially the ball was resting. So whenever a ball is released from a height, the initial, your u, which is the initial velocity here, is 0, taken to be 0. Velocity is just like speed. From the formula, you can get velocity. The SI is meter per seconds. So that is just like meter over seconds. What is meter over seconds? Distance over seconds. Distance in meter, time in seconds. So that is just like distance over time. What is distance over time? Speed. Speed, velocity, instant. Speed is just like instantaneous velocity. So speed is equals to distance over time. So when you're looking for velocity indirectly, you're also looking for speed. Sometimes they call it rate. That is also speed to us. So number 5, you take your u to be 0. Remember that u means initial velocity, initial speed. When I drop a ball down, the initial speed here, my u is taken to be 0, while my v is the final velocity. I'll use a minute or two to pause the questions and the solutions for us to grasp it properly well.